Hi everyone, welcome to this video. As you all can see on your screens that we are starting up with a unit current electricity, and below that it is written it is NTSE special. So of course, as you know, on our channel we are basically covering class 10 curriculum, and of course class 10 students face a very prestigious exam NTSE during their class 10. So of course we will study about that exam also. So today we are starting with the chapter current electricity. It is the most important chapter and my personal favorite. So let's get started. Just pull up your socks. We'll be covering the entire theory in the coming 4 to 5 lectures, and then we shall solve a lot of problems. Okay, so let's get started. As I said, we'll be covering the theory in entire like 4 5 videos. So yeah, this is the first video today. The first thing is the charge. What is a charge? Have you ever heard of it? Yes, we have heard of a charge. We have heard of a charge when we studied the structure of atom. Structure of atom. There, our teachers taught us that in an atom we have a center nucleus and we have outside orbits. The orbits in which this is the center nucleus, and outside we have orbits in which the electrons revolve around the nucleus. Right, here are the electrons. Here we have protons and neutrons. Protons are positively charged, neutrons are electrically neutral, they don't have any charge, and electrons are negatively charged. Am I right? Of course. There we have heard of the charges negative and positive. Yes, there are two kinds of charges. One is positive and one is negative. Okay, that's the first thing. Now, how much charge do these electrons and protons have? So, the answer is electron has a charge of minus 1.6 into 10 power minus 19 coulombs. Now, what is coulomb? Coulomb is the unit of charge, SI unit of charge. Okay, so if someone asks us what is the charge carried by the electron, so we would say clearly, okay, electron carries minus 1.6 into 10 power minus 19 coulombs, right, of charge. Whereas proton carries plus 1.6 into 10 power minus 19 coulombs of charge. These two carry equal amount, or I should say equal magnitude of charge, but the signs are opposite. If one is negative, other is positive. If one has sword, other has shield. Both are ready to kill each other. Okay. This is the reason why atoms are said to be. Okay, let me change the color of my pen so that you know there is some difference here. Okay. Atoms are electrically neutral. I am talking of atoms, not ions. Electrically neutral. Got it? Number of protons equals to number of electrons. So the charge carried by electrons is equals to the charge carried by the proton, but they are opposite in magnitude. Magnitude is same, opposite in the charge we can say. Okay, so this will neutralize this one. Hence, there is no net charge. That's it. That's all about the charge concept of charge. Okay. So what did we study in charge? Charges of two type, negative and positive. Then we studied about the electronic charge and the protonic charge, their magnitudes, their sign, their units. SI unit of charge is coulomb, and why the atoms are electrically neutral, because the number of protons equals to number of electrons. Got it? Now let's move ahead to the next slide, which says concepts of current. Concept of current. Now what is current? Current is nothing but the rate of flow of charge. Rate of flow of charge. Now, when the charge flows, how much charge flows in how much time? That is current. If I say there is 10 coulombs of charge, 10 coulombs of charge that flows in 10 seconds. So, you will say 1 coulomb of charge flows per second. This is nothing but current. Since this was devised by the scientist Ampere, we term this unit coulomb per second to be ampere. So we will be writing it as 1 A is in the capital letter, and if you want to write complete amperes, so you will be writing small a, amperes. Okay. This is a general convention. For example, if I say Newton, so Newton symbol is capital N, but when I write fully the Newton, it would be N small Newton. This is the general convention, okay, in physics for units, of course, right? So here I have calculated, I have just taken a very small example. Now if I say, let us take an example, 55 coulombs of charge flows across a conductor. What are conductors, insulators, and all we'll discuss later. Across a conductor, say in 3 seconds. Okay, let's do it 5 seconds. Okay, let me erase it and rewrite it. In 5 seconds, calculate the amount of current. So, calculate it and tell me. Calculate the amount of current that flows. So that is nothing but charge flown 55, but total time taken, it is 11 amperes of current. 11 amps of current. Correct? So that's it. Okay. Now this is what I told you now. This is like, what is this? I just told you definition. Definition is current is defined as rate of flow of charge. Now, what is direction of this current? Tell me. Tell me. Current flows from a positive terminal to the negative terminal. Have you seen a battery? Of course, you might have seen it. A battery has a positive terminal and a negative terminal. So when I connect a wire like this, my current would flow in this direction. So this is flowing from positive to negative direction outside the battery. Outside the battery. Inside something else is happening. We will discuss it later on when we'll study about the battery. Current flows from positive to negative terminal outside the battery. That's about the direction. Now, when we talk about the direction, can I say current is a vector quantity? Current is a vector quantity because it has a direction. But here I am wrong. Current is a scalar quantity. Current is not a vector quantity. Correct. Okay, it's a scalar quantity. Now, how it is not a vector but a scalar even when it has a direction? Yes, that's a very good question. My dear children, when I talk about a vector quantity, I hope you can see it here in this corner. Let me say force. Okay, so when I apply a force on a body, say this be that block, now I am applying the force from this side. So direction of application of my force is this, towards my left. Now when I apply this force, this box will move towards the left. Now when I change the direction of application of my force, somewhat like this, it's in an inclined direction, the box will go in this direction, right? But okay, so this is my force is a vector quantity because when I change the direction of force, the work done on this block, basically the motion of this block changes, the direction, displacement changes, right? But if I take this wire and twist it, something like this is the positive, this is the negative. Now I place a wire like this. Now I have twisted it. I have changed the direction of wire, but my current value will not change. It will, okay, now you will say, sir, direction has changed. No, direction is not changed. It is still flowing from positive to negative. You have just twisted the wire. Okay, so when we twist the wire, there are no changes. Had it been a vector quantity, there must have been some changes, but here we have no changes. So this is, there are no changes. So this is a scalar quantity. There are no changes, hence it is a scalar quantity. Now one more thing, there is a law called law of vector addition. Okay, let me change my pen color. Okay, let me write it here. We have limited space, so yeah, let's take, say, green color. Okay, so what I was saying, yeah, there is a law of vector addition which we shall study in the forthcoming lectures. I will teach vector analysis also. Well, it is not very important, but okay, after this this topic you will be studying in your class 11, but okay, we shall discuss few things. Law of vector addition. Whenever this law is satisfied, the quantity is a vector quantity, but this law was not satisfied by current, hence it is it's a scalar quantity. So there are two reasons to admire why current is a scalar quantity, not a vector. First is, whenever we change the direction of the say wire, the magnitudes of current, the nature of current does not change. Second, current does not follow the law of vector addition. Hence, current is a scalar quantity. That's it with the current topic. Now, there might be some additional topics that might link to current, but we shall study it later on. Okay, since it's our first class, let's stick to the basics. Now, concept of potential. Now, what is potential? If I say he is a boy, this is a boy, he has high potential. High potential. So, what will you understand? This guy has some potential, some has some capabilities. If I say he has capabilities, right? If I say he has high potential in cricket, so you will say, okay, this guy is very much talented. He has high capabilities to play cricket, right? That's okay. That's the meaning of potential. Similarly, if I say this be a wire that is connected to a source of current, source of current means current is coming out of it, like this, and it is connected to a sink of potential V. Potential V. Basically, if I say a conductor is connected across a potential V, what does this mean? Basically, consider this be a wire. Okay, now this is very important concept, please try to understand. Now if I connect it across a, say, device that is allowing the current to flow. Now, how is it allowing the current to flow? No, this is not the correct way to explain you. Let us take another example, then it will be very much clearer. Okay, you might have studied this. Whenever I take a glass of water like this and fill in the water inside it, say blue color, I have filled water inside it. Now I make a small hole here and connect it to another glass which is empty. So water will start flowing in this direction into this glass. Of course, why? Because this glass has higher potential to supply water, and this glass has lower potential. Potential means capability, ability, whatever you like, you can use it. Potential, right? So this has a higher potential and this has a lower potential. So water will be flowing from the higher potential to the lower potential. Similarly, our batteries. Let me take an example. Let's take a 9-volt battery. Volt. Okay, we'll discuss what is volt. Here we have a positive terminal. Here we have a negative terminal. I told you current flows from positive to negative. So you can easily say that positive terminal is at higher potential and negative terminal is at lower potential. Of course. And yes, that is true. Negative is always at the lower potential and positive is always at the higher potential. That's the concept of potential. Now that is the concept, but when we go for definition, the definition is potential is defined as the amount of work done in bringing a unit positive charge from infinity to a point. Now, what does this definition mean? You will understand it by the course of this course when we will be studying the things in more detail. I'll explain these things gradually, but for the time being, you can consider it to be the equation, the definition. But now, just understand the concept of potential as that we have one higher potential terminal, we have a lower potential terminal, and the current will flow from higher potential to the lower potential. That's it. Okay. Now, what is the unit of potential? Unit of potential is volts. Now, I said it is the work done W in bringing a unit positive charge. So, we'll divide by Q. Unit of work is joule, charge is coulomb. Since it is in the denominator, it will be joule coulomb inverse. Also, very sorry, I have written here W. It's not W, it's V. Okay, it's denoted by letter V. Unit of potential is again V, volts, or volts, volts. 1 volt equals to 1 joule per coulomb. That's the relation. Okay, that's it. Clear? You will get the things when we move ahead. For the time being, volt is defined as the work done in bringing a unit positive charge from infinity to a point. Second, we have the concept of higher potential and the lower potential. Higher potential has higher abilities, lower potential has lower abilities. Similarly, in a battery, positive terminal has higher abilities and the negative terminal has lesser or lower abilities. So the current would flow from positive to negative. That's it for now. There are few other things, conventional current, the electronic current, that all things we will be studying in the forthcoming slides, in the forthcoming videos, not in this video. Okay, next. Okay, I guess there is a mistake. Yeah, it's again the slide of potential. We have already covered potential. Moving to the next, the concept of resistance. Now, what is resistance? If I say, let's talk about the English meaning of resistance. If I say this is a bus, well, it does not look like a bus. Let me take a bus. Or let's take this as a car, this calculator as a car. This car is moving on the road. Now, if I place some hurdles in front of this car like this, so this car will not be able to cross the road, will not be able to go through this place smoothly. It will face some resistance. Resistance means obstructions. Resistance means obstructions. Actually, children, when we say, let's use this empty space, okay, whenever we say current is flowing, actually electrons are flowing and the positive charges, the nucleus, are fixed. They do not move. They do not move. Only the electrons, more precisely the free electrons. Now, what are free electrons? I will discuss later. Don't worry. Electrons are flowing. The positive charge, the nucleus, is fixed. So, if I consider this to be the stream of flow of electrons, say electrons are coming like this, someone is coming like this, like this, like this, like this, like this, like this. Okay, and here I have fixed my protons. Let's draw it with blue color. My protons are fixed somewhere here. Protons are the nucleus. So when my electrons will be flowing, they will of course face some obstruction by these nucleuses. Why nuclei? Because these electrons will be attracted by the protons. It's positive and this is negative. So while flowing, they will face some obstruction, some resistance, right? Some difficulties, and that is resistance. The obstructions offered by the static charges. The obstructions offered by The static charge. Static means at rest. The static charge units, in bracket you can write nucleus, is termed as resistance. Alright, that's the concept of resistance. Unit of resistance is ohm. OHM. Okay, symbol is this. This is termed as sigma. Okay, unit of resistance is ohms. Let's get back to red color. This is sigma, the symbol for resistance. Is that clear? Yeah, very simple. Now the last topic that we have to cover in this video is Ohm's law. Actually, Ohm's law is very deep and very huge. Entire network theory can be governed using Ohm's law. But we will just take a short glimpse now, and we shall discuss in more details during the course of this lecture series. Okay, now what is Ohm's law? Ohm was a very good scientist, very understanding. He used to understand students, he used to understand the difficulties faced by students. So he said, okay, let us test few things. What he did, he said, if I take a wire, and connect a higher potential here, a higher potential means a positive terminal here, and if I place a lower potential here, lower potential means negative terminal. He said current would flow from here to here. We said, okay, you are right. He said, let that current be I and the difference in potentials be V. Difference in potential be V. Difference, why I am talking of the difference? Now let me explain it. If I say this is a rich fellow, this is a poor fellow, who is, like, if I compare, the person with more wealth is this. But if we want to compare how much more wealth, so say this person has 100 rupees, this is 10 rupees, so he has more of 90. He has wealth more of say 90 rupees, the rich person has 90 rupees extra. So their difference is less. But when I say this has 100 and say 50 rupees and this is only 5 rupees, so I have increased the difference. So when I increase the difference between their potentials, the poverty difference increases. Similarly, he said, if we increase the potential difference between the two terminals, the current flowing from the positive terminal to the negative terminal would increase. Let us go back to the same example we were talking earlier. This one. If I add more and more water in this one, more and more, so more water would flow from here to this empty container. Why? Because I have increased the potential difference. Similarly, if I increase the potential difference between the two terminals, the current would increase. This implies potential difference V is proportional to the current flowing through the conductor. Now what is conductor? Conductor is anything that allows the flow of current. What is insulator? What is semiconductor? That we will discuss later. Don't worry. For the time being, the voltage difference, the potential difference applied across the terminals of a conductor is directly proportional, or no, this would be the wrong statement. The current flowing through the conductor is directly proportional to the potential difference applied across the ends of the conductor. Given he had some conditions, physical conditions, like temperature, pressure, etc. should be constant. Temperature should not change. If temperature changes, current and voltage things would not work properly. Okay, that also we will study, but for the time being, V is proportional to R. V is proportional to I. Now, whenever we have to remove this proportionality constant, we need a proportionality constant, which was found to be R. R is resistance of this conductor. Okay, so this is the Ohm's law equation, and this is a universal equation. This is a boon. It helps us a lot to study more and more details of the subject network theory. But since we are here at a smaller level in class 10 only, this equation is going to just lead us to heaven. This is best equation used everywhere. Okay, so here on we'll end this lecture. If you have any sort of doubts, any sort of suggestions, please feel free to connect either through my Instagram, or you can just leave a comment in the comment section below. Thank you so much. Have a good day.